Happy Friday, everyone, and welcome to another Distributed Tea Time. As always, I'm Adrian Howard, a developer advocate at Cockroach Labs.
And I'm Rob. I'm a technical evangelist at Cockroach Labs. And today we'll be looking at making your applications global. So in a previous episode, we looked at making your database global, but that's only really half the battle. It's actually a multi-stage process. You can have a database that is global and an application that's local, and you're still going to get terrible performance from your application. So we're tackling the other half of the battle today.
Yeah, we always like to say, keep your data close to your users, but really, you need to keep the whole thing close to your users, because if your application isn't close to your data, then you're not going to be getting those gains in latency. So what we've done is we've put together a little demo. I built a app, and I guess I can go ahead and show that off. So I built a little app called Rotorose. So this is our fictitious online coffee shop.
Or is it fictitious?
Or is it fictitious? Yeah. We didn't put in where you can actually order or add to a cart, but and so this is just to show off, our data that we have. Is it co-located?
You could say that. Yeah, it resides within the country where the market is being served. So, for example, if you're in the States and you want to buy coffee in the States, you would go to the US or United States market, as you can see at the top of the page, and you would be getting price information, product information from the States. I'll show you what the database looks like shortly, but we'll take you on a whirlwind tour of the app first. And essentially, this is a scenario whereby a local company, obviously I think a coffee shop is a very bad example, especially an online coffee shop that sells globally.
Yeah.
I guess we've probably got some kind of souped up t-shirt cannon that we can launch coffees to the United Kingdom across the pond. But I don't know, we haven't really thought that through, but we had a cute little example, a toy example that we could show everyone.
And so as you can see down here at the bottom, we are showing you which CockroachDB region we're hitting with this application, and then which Fly region. So this application is deployed to Fly.io. So this is if you haven't played with Fly.io, I highly recommend it. Yeah, I've had a lot of fun with it, and I'm slowly moving everything over to it. And then also, because this is a global application, we also localized it, so we are showing you which locale you are currently using. And then, if you happen to find this, we have a little link to the repo as well. But one thing that we did is we are keeping track of, on the server time, how long it takes to make the query. So you can see next to the menu we've got a 5 milliseconds, and that's how long it takes me to get the information from the United States, because this app is deployed in US East 1 region, and my data is stored in the US East 1 region, so pretty fast.
Worth qualifying that this is just the timing that it takes from the server to reach the database and back again. It's the round trip from server to DB, not from client to DB. That might be an interesting thing to add.
Yeah, we should definitely add that. So you can see if I click on United Kingdom, 77 milliseconds. Mexico, 69 milliseconds, because that is, I believe, housed in US West 1?
Correct.
Okay.
Yeah.
And then Germany, you can see 96 milliseconds.
And so that is...
No, go ahead.
Sorry, UK data is in the UK, in Ireland actually,
okay.
And Germany data is in Frankfurt. And I'll show you the regions in a bit.
Yeah, so I guess talking about the data and where it's located, I can pass it over to you, and you can go through all of that.
Sure. So do you want to flick over to my screen? Lovely, thank you. It looks exactly the same. So this is me now. It's going to say that I'm getting really good latencies from the States, and that's because we're only timing the States. I'll show you what the hops are going to look like in a minute, and it's pretty horrifying. This is just like, we've gone global. It's badly architected at the moment, but we can fix it, and we will fix it. So UK, I'm getting 76 milliseconds, and you might be wondering, well, you're in the UK, why are you getting such slow times? It's because my app, while I'm connected to an app in the States, my data is actually in the UK. So I'm getting a hideous round trip, which I'll show you. And again, Mexico 68 milliseconds, Germany 95. So it's very equivalent to Adrian's, because we're essentially seeing the same benchmarks. We're seeing the same hop to the same fly region. So, but it's not representative of what I'm seeing. If this were any slower, it would be painful. We're still returning within the order of 150 milliseconds, probably total. But it said that anything over 100 milliseconds is perceptible to users. So,
and then also we only have 3 products right now. So I imagine those times would go up if we had a larger menu of products.
Yeah, and it would depend on the amount of data you're sending across. Yeah, of course.
And just to reiterate, the current setup that we have is we have it deployed to one region in US East 1, and then we have our database, which is a CockroachDB serverless database, set up for multi-region, deployed across 4 regions.
Yeah, and just to show how the localization works, we've got the translations of the products in the database as well. Hopefully this is correct. Menu.
It's correct. I'm taking Japanese right now.
Oh, yes, I forgot.
Somebody please tell the people team that I'm using what I'm learning.
But you'll notice so the locale has changed, but the response times wouldn't have changed because we're still fetching data from across the pond, but also the data to translate into different locales is global data, and I'll show you that as well. So awesome. I'm just going to switch back to UK before it confuses me.
Yeah, I meant to ask you. It's so great working with Rob because he hands me a database and then I just build the application. It's like back whenever I was a software engineer and I just worked with the backend team. So yeah, I forgot to ask you if we globalize the translations database. That's good to hear.
We have. So this is an overview of the cluster. As I said, we've got a 4-node cluster. There are nodes in Frankfurt, Ireland, North Virginia, and Oregon. Data for the Mexican market is stored in Oregon for no other reason than why not. And the rest of the US is stored in North Virginia, whereas London data is in Ireland and German data is in Frankfurt. This is very flexible. We've configured it so that we'd say, if the market is UK, store it in US West 1. But that could apply to any rules, and you can apply multiple markets to a specific location. So hopping over here, this is a high-level bird's eye view of the cluster. So there are the 2 nodes in the States, there are 2 nodes in Europe, and there's a global table holding the translations. This is all one database. The US products are
Hey Rob, what do you mean by a global table?
Yep, good question. So there are different table topologies in CockroachDB. So global tables means that you can get fast reads from wherever you are in the world. So for reference data, like translation data, where you might have Japanese speaking customers, both in Japan, but also in the States and wherever else in the world, you could also have Spanish speakers wherever in the world. But that means the data should be global. It should be very fast for reads wherever you are in the world. And it's seldom updated. So we can take the hit. There's a slight hit on write latencies with global tables because you need to make a write request, which needs to be replicated to another region somewhere else in the world before the write comes back as committed. So you can achieve quorum on your write.
And this really makes sense because locality is set in the browser and not at any other level.
Yeah.
Yeah.
Yeah. So this is a higher level still. So this is me. This is the European database. This is Aydrian, and this is the US database now. For Aydrian, he's making a request to the local application, which I believe is deployed in Virginia. It talks to a database which is in Virginia. It comes back to the application and then back to him. So we're talking in the order of 600 miles round trip. So very, very quick if you're thinking of the speed of light and how fast data travels. For my request, however, I'm connecting to an application across the pond. That's 4,500 miles, give or take. It's coming over to the database in Ireland, 4,500 miles, so 9,000 miles so far. It's going back to the application, 13,500 miles, and then it's coming back to me, 18,000 miles or 29,000 kilometers for one request, which is, it might be, relatively performant, but it's an unacceptable amount of distance, I think, for any request to make. It's silly, and especially if we were porting lots of data over the wire, it's not scalable. So I'll show you what the database looks like under the hood.
Oh,
So,
1 second. I
yeah, of course.
know that when you were putting this together, you mentioned super regions. Can you explain that to me?
Oh, I would be delighted to. And thank you again for reminding me to explain these things.
No
So,
worries.
in order to be compliant, let's say, there is a regulation that stipulates that UK data has to be protected if it's being transferred over to the US. I think there was a legal case recently recently in the last couple of years called Schrems 2, whereby I think Facebook, I might be wrong with this, mishandled data and was in breach of the way that law protected European citizens or UK citizens' data. That's actually being looked at again in the next couple of weeks. So if we don't want European data, for example, to leak out of Europe, we can put what's called a super region around it. And a super region is just an abstraction on top of regions. You don't have to worry about, once a super region's configured, you don't have to worry about it again. I say create a super region for these two regions, which in my case is the Ireland and the Frankfurt database regions. And Cockroach will replicate data between those, but nowhere else. So
Nice.
you know that data isn't going to reside in the States if it's meant to be residing in Europe. And it's the same the other way around.
But it's just a situation of residency. People from the States can still read the data. It's just where it lives.
They can indeed. We could lock that down as well, obviously with user permissions and views and what have you, RBAC. But yes, by default, the data will live physically in those locations. We can
So we're still
rehome
seeing
data.
one logical database.
Yeah, one logical database. Let's say I were to pack my stuff up and move to the States. We would, and I say that quietly because my family are downstairs and it feels really wrong saying that.
Do it.
I might want my data to reside in the States because I want fast lookup times to my data, and we can rehome data. The first, if it's enabled on the database or the table, the first update I make to my data rehomes the data over to the States. And if I move back to the UK, I rehome my data back to the UK.
But by default, let's say you come for, let's say, marketing offsite and you access your data, it's going to stay over there. You're just going to see some latency until you go back.
Yeah, without rehoming enabled, yeah. So,
awesome.
Yeah, so that's how bad things can possibly be. And let me show you how the tables looks. To show you tables, we'll see that there are two tables. There's a product table with around 12 products in.
Can we bump that up a little bit?
Yeah, of course.
Yeah, that's better. Thank you.
And there's an internationalization table with approximately 20 rows in. The internationalization table is global, fast reads from wherever you are in the world. And let's have a look at that. I'll show you in a minute, actually. And the product table is regional by row, which means we pin data to a specific region, or we house it. So let's have a look at the products. So 262 milliseconds, if I run it again. Yeah, so we're around the 250, 300 mark for request lookup times, and that's definitely perceptible to users. Users will notice that delay. But if I were to limit the data, let's say where the market equals UK, run the same query again. Now it's taking around 24 milliseconds, 23 milliseconds. And that's because Cockroach knows that the UK data or the UK market data is in the EU West 1 region. Therefore, it only needs to make a lookup to EU West 1 to get the data. Super, super snappy. If I were to ask for US data, 91 milliseconds. And that's because it knows that US data is physically housed in the US. And that's why it took so long to fetch all of the data, because it's having to make requests to all 4 nodes in the database and pull them back.
And it should, just a note, you are connected to the database through the shell, which means you are connected to your local cluster. You're no longer going through our app.
Yeah, so that's right.
That hop.
So there's a global load balancer in front of Cockroach DB serverless. So if I show my gateway region, no, it's select gateway region. Show me that I'm in US West 1. If you were to connect to the console and do the same query, it would return US East 1. And that's what the application's seeing. It's seeing that its closest region is US East 1, so it's making requests against there. Let's have a look at the internationalization table now. Where language equals English. And again, this is a global table, and we've got nice low latencies from that table, because that data is everywhere. If I look up Japanese data, same low latencies because the data exists everywhere. So nice, quick translations wherever you are in the world. And let's do some more realistic queries now. So I'm going to select the product identifier, amount, and currency, and the translation for all of the products that are in the UK market, and I'm going to translate it to English. So 23 milliseconds, I've got all of the data that I would need for the front end. I can change that to Japanese, exactly the same latency, 23 milliseconds. But if I were to, let's say, look for data in the Mexican market and want to translate the data to Spanish, 143 milliseconds. That's CockroachDB having to make a trip across the pond, fetch the data, and then stitch it together with the localization data, which happens to also exist. It would probably get the data from, in fact, I'm not sure where it would stitch the data in, but again, if you're looking for data across the pond, it's going to take a while.
Yeah, and just to explain how it's happening on the app, we're using something called I-18 Next. And Sergio, if you use Remix, then you know Sergio. Sergio created a Remix I-18 Next library, and so what is happening is whenever the application loads, it looks at your locality and it pulls all of the translations and caches those. So we're not having to make any kind of joins whenever we bring back. That's just something that's happening on the server side when it's rendering the web page.
So we've seen how bad it is if I'm trying to access a single application that exists in the States. Should we scale up now and see how that increases, it reduces the latency?
Yeah. So I think we've done a really good job of explaining what the problem is and getting down deep into it and looking through it. That's something that Rob is very good at. You should also check out some of his videos. I know he has one coming out talking about ranges. So if you're really interested in deep down how Cockroach is managing all of this, stay tuned. Things are coming. What? I like video content. Let me go back over to me. So we talked about the problem, and obviously the way to solve that is to put your application in more places. And so what will help, I know there's a lot of talk about Edge, but what will help the most is getting the application deployed close to where your database lives or where your users are going to be. So we're using fly.io for the deployment. Currently we are deployed to one region. Let me go over to my console here.
Worth mentioning that while we're doing this for Fly.io, this would be the same for however you deploy your applications. If your applications are in the States, but they're deployed in US East 1 of AWS, you're going to have exactly the same problem.
So Fly has a great CLI tool, and what I can do is inside of my application directory, I can run the command fly scale, and then we tell it how many machines we want to scale up. So we're going to add one machine, and then we give it the region. And so we're going to deploy another instance of our application in LHR. Fly uses airport codes for region names, which obviously Rob is a fan of. But LHR, that is London Heathrow, which is going to be closest to Rob. It's not going to be exactly where the data center is, but I think it's going to be negligible, the distance. So let's go ahead and do that. And we'll watch it go. Okay, so it's like, are you sure? Yeah, let's go ahead and do it. And so it's executing the scaling plan.
I guess it makes sense. I guess it makes sense having the airport codes because you'll get an airport in a city, but then you could call it London, couldn't you? I don't know. It's a global 3-letter thing though, so they've got there's reason for it.
Well, there's a London, Ontario, so
that's true, but it's not LHR.
Yeah, true. Yeah, great. So now we should be running an extra machine with the application in London. So do we want to switch back over to you?
Yeah, sounds good.
All right.
So I haven't refreshed my screen yet, so I'm still targeting the IAD. What airport's that?
IAD. That's it's in DC.
Oh, DC. Okay.
Yeah.
Right. So let's refresh. Okay. So now my CockroachDB region is EU West 1. And my fly region is London Heathrow. the fly installation I don't believe is running at Heathrow.
I mean,
So
maybe.
yeah. So let's run these queries again. So Germany, I was running about 90 odd milliseconds. Now, because it's calculating the distance between the LHR fly IO, the London-based fly region, and the database where the data is actually residing, we get better latencies. So for example, UK, it was taking about 80 milliseconds, I think, for me to do the same request last time. Now it's taking 28 milliseconds, 15 milliseconds. So it's very, very snappy now. United States, whereas before I was getting 6 milliseconds, 5 milliseconds, now it's actually more realistic because my request is making the hop from my house to London Heathrow, to the States, back to London Heathrow, and then back to me. So we've halved the distance that my requests are having to go in order to make a request to the States, and we've reduced the amount of time that my requests are having to make for the UK and Germany by I don't know. I don't think science has a number that for that amount of factor, but it's much better, and this is a much better deployment model for a global application.
Mm-hmm. And what's great, and I'm sure you can do this with anywhere you deploy, is you can put these deployments out as your market grows. So maybe this is a situation where Rotorose was a local East Coast company, and then they extended into London. And so if that's where your target base is, you can make sure that you have applications starting up. Cockroach Labs, we just added a location in India, so we could very well put a region in our database that targets India and deploy another application in there, and they will have low latency. So this is not something that you need to go global completely to begin with. You can scale this over time.
It would be that would be helped when we're able to add and remove regions from CockroachDB serverless clusters. At the moment, you can't,
Right.
but you can back up and restore the data to a cluster with more regions. But with serverless, you're not paying for what you're not using. So if we've got nodes in the Mumbai data center and they're not being used, we're not being charged for them. So we artificially kept this cluster small just to keep it simple. But I could have deployed to an additional two regions, Singapore and Mumbai, and it wouldn't have cost us anything. The cluster itself at the moment isn't costing us anything because our traffic is very low.
Yeah. Yes. So we are still working within our free allowance that we get every month. And that just changed. It's 50 million request units a month and
10 gigabytes of storage.
10 gigabytes of storage. Yeah.
Yeah, so I don't think we're very close to that with our successful coffee company yet.
Yeah.
Cool. So, well, I wasn't planning on us blasting through that so quickly.
I mean, we've only done a half hour.
I know.
I'm used to ending on like the hour, so I'm like, oh well, we did pretty good.
We did. Yeah. Is there anything else you'd like to cover while we're on the call, or should we give people their time back?
So we mentioned, for global tables, translations are a good example. Do you have any other examples that would be good for using a global table?
Yeah, any kind of reference data, I would say, is a good candidate. Data where you want it to be global. So, for example, PII probably wouldn't be a good use case for global data, but data that we could have put the product information in a global table. If you wanted like super snappy times, if you wanted to see how much products cost in Germany, but you didn't want to get the products actually from Germany, we could have made the product table global. We could have maybe we could have abstracted the product table into two. We have a core product table, and then maybe a product market table, which stores all the market specific information. But with retail companies that operate globally, typically there'll be country specific products. So you might not want all of the products to be available everywhere. It might just be confusing. So I think there's... Yeah, go ahead.
Go ahead and finish, and then I'll go with the question.
But there are use cases where I wouldn't recommend global. So there's anything with PII, you don't want leaking out everywhere, and anything where your write latencies are really key. So that's a good use case for regional by row. If you need to keep your data in one place, or you want fast reads and writes to a multi-region database table, then that's a really good topology, the regional by row, where global tables falls down a bit. I would recommend global tables for anything where you've got high read, a much higher read ratio to write ratio, and the data has to be available everywhere.
And one more thing on this topic, and then I'll go to the question in the chat. But I'm guessing trying to create a global application by just making every table in your database global is a bad idea.
Very bad idea. Yeah. So there are anti-patterns to be aware of in Cockroach as well. So when you're creating a global anything, it comes with responsibilities. You go from not really having to care about the locality of your apps or your users or anything if you're in one location because everything's super snappy, to now I have to start thinking about, I guess we go from being maybe CPU bound to being network and distance bound. Like, we can only make so many requests if our users are spread out all over the world and we only have one global one database. So yeah, if you were to deploy something, make every single table global, your write latency would be much slower because you're having to do that replication. Obviously, if your use case demands global tables because you need the data everywhere and it needs to have very fast write latencies, you can achieve the same with different patterns. It doesn't have to be the global tables pattern, but I would recommend, if we could put a link maybe into the table topologies patterns in YouTube, I think that would be super helpful for people because it has, and we've also got, maybe share a link to the toolbox as well, because we've got a topology chooser. So you plug it, in fact, I can show you, I'm here now. I'm sharing my screen.
Yeah, just Slack me any links and I'll put them in.
Yes, this is the Cockroach DB toolbox, and within there, there's a topology chooser. So this is something that I created with Paul at Cockroach Labs. I think he's
Shout
watching.
out to Paul Scanlon.
Whoop, whoop. And we can choose various parameters. So for example, let's say our cluster was multi-region, like this one. We'll do it for this. I want my users to be all over the place. They're not just going to be, so a read locality of local means all of my reads or most of my reads are happening from one region at a time. That's like a good case for follow the sun model. That will move your data to where it's being read from the most. But if let's say everyone's reading the data all at once, it's a 24/7 operation. Let's say I can tolerate write latencies. So that suggests the global tables topology, and it shows you, and it then links off to the global tables topology in the docs, and it gives you an example of a global table in code. Let's say we can tolerate stale reads. So that allows Cockroach DB to read from a replica instead of the leaseholder. So for example, in fact, let me just, I don't know if this is going to work, but let's try it.
We're doing it live.
Let's just snap over to my whiteboard. And come on, find it. Is it going to work? It should have snapped over by now. No, it didn't find it. Oh well. So essentially, if I make a request, Cockroach DB knows that there is if I'm asking for a specific piece of information, Cockroach knows which node owns that small piece of information, because the data is broken out across the nodes as replicas or ranges.
There we go.
And if I want that, if I want to get the data from the source, like atomic consistency, Cockroach knows that it needs to route me to the leaseholder of that data before it returns it to me. If I allow stale reads, it will get it from the closest replica, so without having to make that network hop to return the data, at the cost of slightly stale data, but it's opt-in. You don't have, like, Cockroach DB is strongly consistent and ASIC compliant, but you can opt in to slightly stale reads if you need that extra performance that you might get if you can tolerate the stale reads. But if, for example, we need to domicile data, that switches over to read.
What's a stale read?
Good question. Essentially, it's you can ask for data from a point in time in the past. So if I say, rather than returning me the actual current data from the database, which would require a call to the leaseholder node for that data, I can say, give me data that is, let's say, ever so slightly stale. I'll do a query now. Let's do a query against select star from product as of system time, and then we can say there's actually a function helper. So follower read timestamp. That returned data, I think it's around 4 seconds old. So if there were changes made to that data within that 4-second window, I wouldn't see them in here because I've allowed a slightly stale read. Whereas if I do this, data is guaranteed to be consistent with the latest writes in the table. So if you need asset compliance, you don't need to use follower reads, but they're a useful tool if you need them.
Nice. I think I stopped you on that one.
No, that's fine. And the only thing I was going to add to that was if you need to domicile your data to particular regions, we then recommend the regional tables in this topology chooser, and there's an example.
Nice. So we do have a question from the chat. They asked if we could discuss cold starts.
Sure. Yeah. So, in fact, that's something that Aydrian and I were looking at before the call. Whenever you're dealing with serverless technologies, like Fly.io allows you to operate in a serverless kind of way by scaling up your application and scaling down to 0. CockroachDB serverless can also operate in the same way. Essentially, CockroachDB serverless to the consumer is a serverless technology. You don't need to run your own servers or anything like that. There are no long-lived, provisioned, dedicated servers that exist to you. It's a multi-tenant Kubernetes environment. And we deal with cold starts by keeping a pool of SQL pods, which are the pods that you would interact with in order to run SQL statements, warm. So if we don't receive any queries for a period of time from your tenant, we'll scale your tenant out of the cluster, and you won't be incurring any charges at all because it's not being used. And then when you're ready to make requests again, we bring in a pod that's already warm from that SQL pool right into the cluster. And it's very, very, very low latency. The pods are already there. They're already ready to go. And it's
I think it's worth mentioning that we have 2 types of pods for our serverless. We have our ephemeral pods, which scale up the compute, the SQL querying, but then we also have pods that are not ephemeral, and those are what hold your data. So
yes, that's a really good
when
point.
we say that we scale down to 0, it's not like we delete the pod and your data is gone. Yeah, so there's 2 different
really good
types.
Point. Yep. And it's good to make that separation because that allows us to scale up the SQL pods, the ephemeral compute pods, if you will, from the storage pods. So each can scale independently of one another depending on your workloads.
Yes.
Any more questions from the chat?
I was like, I had one and I forgot. Oh my gosh, what was it?
Was it around topologies?
It was before topologies. Well, maybe it will come back. Yeah. Oh wow, we've gone like 5 minutes over.
We've done it in good time. 35 minutes.
All right, we have another question.
Okay.
Depends a lot, but would you recommend letting the scalability of CockroachDB brute serve all the reads or use a Redis cache layer for common read data like a global table? Can CockroachDB eliminate the complexity of implementing a caching layer?
Good question. And it's actually a question I had for the Cockroach Labs team when I was inducting myself to CockroachDB. And the advice I would give is only implement a cache if you test your system and know that you need it. And that was the advice I was given way back when I asked it back in 2018. So use CockroachDB because it has its own caching built in. So if you make a request and it's slightly slow initially, it will be quicker the next time because the query has already been cached and CockroachDB can look it up very quickly. With the CockroachDB cache, you'll still maintain asset compliance. So your data will always be consistent, even if the data is in a cache. If it needs to be invalidated, it'll be invalidated and you'll get fresh data as the next query comes in. But if you are putting your data into a Redis cache or any other cache for that matter, you lose the ACID compliance guarantees for the reads because the data is no longer being managed from within Cockroach. And there are a number of things you could do to improve the read throughput. If you're keying your data, let's say the primary key has very good uniform distribution. So for example, a UUID, or maybe even like a unique username in conjunction maybe with an auto incrementing ID as a composite primary key. You get good distribution. So CockroachDB will distribute the data across nodes more evenly. So each node can handle reads for a fairly nicely distributed portion of the data. And as you increase the size of the cluster, so too are you increasing the ability for CockroachDB to scale out that compute horizontally. So benchmark it for yourself. I'd be interested in seeing what your results are. But my advice to start off with would be don't try caching unless you know you need it.
You've mentioned a couple times ACID compliance. Could you explain that?
Yep. So there are 4 letters: atomicity, consistency, isolation, and durability. And these are 4 key tenets of a relational database management system. So ACID compliance essentially ensures that your data is atomically updated, therefore it's consistent. Transactions happen against the database in isolation. So for example, 2 transactions wouldn't be operating on the same amount of data and corrupting data in a certain way. Like you've got good, especially in the case of a serializable isolation database, which is what CockroachDB is, you would get one transaction after another in serializable isolation. So you always know exactly what the state of your data should be and ultimately is. And the last part is durability. Obviously, your data needs to be durable, and on top of CockroachDB's raft management of the data and the way it replicates data, so it operates on the raft protocol, which is kind of a variation of the Paxos algorithm that was introduced by Google, I think. You've got good durability and resilience for your data.
So we got another question. Is it possible to switch from serverless to enterprise, but keeping the DB fully managed by Cockroach Labs?
So there needs to be a distinction between what we mean by serverless and enterprise. Serverless and dedicated are 2 different plans, but they both sport the enterprise license. So you can do everything that you would need an enterprise license for, you can use in serverless, and you can start out for free. But if you wanted to migrate from serverless to dedicated, that would be at the moment maybe like a backup restore operation. So something to be aware of. If you need to have a specific amount of nodes and you want to size those nodes specifically, then dedicated is a good choice. If you don't know what your traffic is going to be and it might be spiky and you need to be able to scale down to 0 and not get charged for what you're not using, serverless is a good option. But I think it depends. There's on the website we've got the reasons for using various types of plans, and the third one is self-hosted. So if you want to download the binary, maybe wrap it in a Docker container, orchestrate it in Kubernetes, however you want to do it, you can also do that. But we call that, I think, CockroachDB Core. It's the core version, so you don't get the enterprise features unless you buy the enterprise license and apply it to the cluster, at which point it becomes an enterprise cluster.
I remembered my question.
Okay.
So with the Rotorose setup that we have, what happens if we lose a data center? What happens if we lose a super region?
Okay, so that's a good question. So they're all good questions, but essentially in our super region, we've got 2. I'll switch back to my. Here we go. So
the picture.
In each super region, we've got 2 regions. If we lost one of those regions, the super region, the region would carry on working. And that's because at the moment we've configured the database for zonal survival. So there are 2 different types of survivability goals in Cockroach. You can set it to regional survivability, where you'll need at least 3 regions, and the data will be replicated across the 3 regions, I think with a default replication factor of 5. But we've got a replication factor of 3, and we're replicating across availability zones within the regions. I think it might be. Let me show you. I'll have a quick check. If I do show configuration zone configuration from table product. Okay, so Yeah, number of replicas is 3. So we'll be probably in 1 or 2 machines over here, 1 or 2 machines over here, but in a total of 3 replicas for there. So if we lost a region, the other region would continue to run, but if we had 3 regions, we'd still have 2 that could serve data. So I hope that answers the question. We can survive. Essentially, what this kind of setup is good for is zonal survivability at best. I would say if we were to lose an availability zone within a data center or within a cloud provider, we would be fine. But I wouldn't want to lose much more than that. Whereas if you were to try and set the zonal, if you were to try and survive regional failures from this, CockroachDB won't let you at the moment because it would require that within the super region you had three regions.
So in each region, is that made up of 3 CockroachDB nodes? Or is each region their own node?
I think there's a command that we could use to find out. Let me have a look.
Because we mentioned that you could download the binary, host it like in a Docker container, do all of that yourself. But whenever you spin up CockroachDB, you want to make sure that you spin up at least 3 nodes to create a cluster for survivability.
Yeah. I'm just going to see if I can find it in the docs. I think I'm close to finding it. Let's try this. No, I'm not 100% sure. I'd need to... And let me get back to you on that, because
Okay.
it would be interesting to see.
Yeah. Some great questions today from the chat.
Yeah, thank you. Yeah, they've been great. Cool.
Feel free to ask anything. It doesn't have to be around this example specifically. Also, if there's something that you would like us to show during one of these tea times, please, you can drop it in the chat. You can drop it in the comments. You can tweet at us using the hashtag distributed tea time. We'll pick that up and we'll work it into our next show. While people are thinking about any possible questions before we end, our next show is going to be in 2 weeks, which I've lost my calendar. Let me find the 28th of July. So we will be back. Let me go back to chatting since you. We will be back on the 28th of July with another show. We're going to be figuring out what that's going to be. So now is the time. If there's something specific you want to see, we can put that together.
At the moment we don't have a plan for it, so we're completely open for ideas.
Yeah. So Rob, question for you. You're still fairly new. In the time that you've been here, what's your favorite thing that you've done?
Ooh. So I've done releases, like press releases on like digital media, which is cool, have my name against. I've done about 20 YouTube videos now on various aspects of Cockroach, which have involved me going a lot deeper into Cockroach than I've ever been before. I love developing the demos that we've been working on, and I think the CockroachDB toolbox is probably one of my prouder accomplishments so far. Just being able to give the power to make good decisions with CockroachDB to the public is very satisfying, because when I was getting started with Cockroach, as I find with every new technology, when I was starting out with Go, it was particularly the case, I'm terrified of making mistakes. I was afraid of writing a single line of Go because I thought I'll make a commit and then I'll be ridiculed for making terrible Go code. Obviously that's not the case. No one ridicules the community on for the most part is lovely. But it was the case with Cockroach, and I think when you've got a very powerful tool, you can make some very powerful mistakes. Like I think with great power comes great responsibility, and I think it's really important to be able to use the tools that you do have to their best in order to get the best out of them. With Cockroach, it's really easy to make good choices. It's easy to make a table regional. It's easy to make data globally available. You don't have to make data globally available. You can operate perfectly happily in one region if that's your requirements. So yeah, I think that's probably my proudest achievement, the toolbox so far, and I'm going to be adding new tools to it all the time. I think I've got about 20 new tools in the pipeline to add to it.
That's exciting. You mentioned that you've learned a lot about CockroachDB since you've come here. What's the favorite thing that you've learned recently, or
Yeah. So I love knowing how the ranges work at a low level, but I think my favorite thing is a multi-region CockroachDB serverless. It's so incredibly powerful. Like, and I'm not talking from an evangelist perspective here. I'm just talking from a developer perspective.
Mm-hmm.
Like, if I had access to a global database 17 years ago when I started my career, it would have been an absolute game changer. And I think it's a game changer now. Being able to house data wherever you want in the world in an instant is just awesome. So I think, yeah, it's so incredibly cool. And that's just from my geeky dev perspective.
From the chat, we have possible idea how to identify hotspots and how to correct them. Do you want to talk about what they mean by a hotspot?
Sure. So a hotspot is a range of data. So let's say, I'm going to try and get this back because this would be so helpful if I'm able to just share my whiteboard. Let's see if
Rob's whiteboard. Here we go. We need to get a whiteboard cam.
I know. It's so annoying. It's going to flick back. It's not going to work. Tell you what, I'm just going to manually move the gimbal so it focuses in on the whiteboard.
Okay.
Let's bring it over.
You've asked one of those questions where Rob gets to draw pictures.
Okay. So if you think of a table,
needs to focus a little bit.
Oh dear.
Can it?
It's trying to focus on me. I'll zoom in a bit more so it doesn't see me anymore. Oh dear. Come on. Can I change the... Come on. It's not going to work, is it? You know what? I'll do it in the air. Just like...
Okay.
Sorry about
that. We need to get you a clear whiteboard that you can just put in front of your face.
That's a waste of everyone's lives. Okay, so a range is, if you imagine you've got a table and you turn it on its side and you chop it into bits. By default, those bits will be 512 megabytes in size, and a megabyte is 1,024 bytes by 1,024 bytes times 512 gives you 512 megabytes. And those ranges are distributed across the cluster. But if your data isn't uniformly random, like I mentioned earlier, like a UUID, CockroachDB is gonna insert the data into ranges sequentially. So let's say you've got an auto-incrementing ID, which we wouldn't recommend using. You're going to be inserting loads and loads and loads of data into one range, and then loads and loads and loads of data into the next range, and that becomes a hot range. If you're writing lots and lots of data within the same area, you're losing out on a lot of opportunities for horizontal scaling because you're constantly hitting the same node, which is why if you're creating a primary key for a table, make sure that it's got good uniform random distribution. So that's a hot range, and that's how to avoid it.
We just covered it. So one of the ways is using a UUID because they are going to be non-sequential. But what is the other way? Either a hash index or...
Yeah, so timestamps are another way to get into a hot range situation because essentially they are, if you're looking at time now, it's inherently sequential.
Yeah.
Whereas if you were to hash shard it, it would put it into different buckets. In fact, let's do this live. I can share my screen again. Let me share my entire screen. So let's create a table. I'm going to exit this terminal and Cockroach demo.
And for those of you at home who are downloading the binary, if you want to try out the enterprise version of the database, you can do exactly what Rob is doing by running cockroach demo, and that will spin up a in-memory database with a temporary enterprise license, so you can kind of play around. And
so let's create a timestamp tz, which let's say it's not nullable, and the default value is going to be now. Then I'll create a primary key, and let's make that the primary key. I don't need to say not null if that's the case.
And for those of you who are wondering what a timestamp TZ is, go to the other part of our YouTube channel and look for the video by Rob explaining it.
So if we insert into measurement, and we'll do, and we'll say, no, insert into measurement, head, and do a select now from generate series 1 to 1,000. Oh, that's because I'm inserting now. Okay, I'll show you what the alternative is. At the moment, if I insert data into this, it's going to be sequential and you're going to have a bad time. If I drop the table now create it in a slightly different way. Let's say primary key default now. I think say create it as a normal index, and then I'll say index on TZ using hash. So now that's created a separate column in the database. So if I insert data into the table now, let's do insert into table, insert into measurement TZ values now. We'll insert a few more. Now if I search for data, the data's in there, but there's also another column. If I show create table measurement, another column which is hidden. So let's select that out as well. Let's do so this is saying this is the bucket ID. So what we do if you ask for a hash sharded index is we say, but essentially we're saying, I know this data is going to be sequential, so split it up into bits and store it in different places for me. So by default, CockroachDB will use a 16 bucket hash. So each of these values has a good chance of being in a different bucket, which improves the uniform distribution of the data. And the way we calculate that is using a call is using the following call. So if I run that, we perform an FMV hash. I can't remember what FMV stands for. I know it's 3 different names of the authors who created the hash. But if we do, and let's do, instead of, we'll do now. I run this a bunch of times. 12, bucket 6, bucket 3, bucket 7, bucket 11, and it's all mod 16. So we'll always be less than 16. Greater than or equal to 0, and less than 16. So there'll be 16 buckets. You can change the number of the buckets depending on your requirements, but that's another way you can avoid hot ranges if you've got very sequential data.
Nice. Yeah, I don't know. I always plop a ID on there that's a UID. That's the way I've been doing it.
Become habit.
Yeah, unless it's like one that doesn't need one, and then I do like a compound ID. But yeah, cool.
Any more questions from anyone, or?
I think that's all from the chat. I mean, we are. I think we're good now. Like we're about five minutes left. So again, we will see you. Let me go back to chatting. Again, we will see you in 2 weeks, July 28th, 9:30 a.m. Eastern time and 2:30 p.m. London time. And thank you for joining us.
Yes, thank you very much.
It's been fun. And
thank you for the great questions.
Yes.
Loads of really cool questions today.
Yeah, I think in the long run, this is kind of how we would love it to be. Is our demo is not the entire time, and we have time to engage and answer your questions. So please tell your friends, come back, bring all your questions. If we can't answer them, we will find an answer. But until then,
And
yep. Oh,
cool. Take care, everyone. Have a lovely
yep. All
weekend.
right. TTFN.
Bye all.